sum of €5,000 was invested in an 8-year government bond, so a savings bond, with the AER rate of 6%. Find the investment at the end of 8 years. Okay, so you're basically doing your future value formula. So you're saying F is equal to P bracket 1 plus I times T. Now let's find out what we have. Future value, we don't know. That's what we're looking for. Okay, P we know is going to be 5,000. It's the amount that they're investing straight away. I at this point is 6% or 0.06, whichever way you want to look at it. And T is 8 years. Okay, let's fill in our formula then. So we've got F, we don't know, so we keep F equal to P, it's 5,000. Open my bracket, 1 plus 0.06 O to the power of 8. My future value is 5,000. Okay, this plus 0.06 is 1.06 to the power of 8. And at this point, you can put it into your calculator. The future value is going to be 7,989.24. So what we're doing here is we're working backwards to find the interest rate. Okay, we know that it's going to give 20% in 8 years' time. So the future value of it, okay, the future value of the investment is going to be the 100% that you invested plus the 20% that it increases by at the end of the 8 years, which is going to give us 120% or 1.2. Okay, so our future value is 1.2 times P. Whatever they invest, it's going to be 1.2 times that amount. So that's going to be equal to whatever P is, we don't know, okay? 1 plus I to the power of 8. So we've just basically filled in the same formula. Now what we do is we're going to solve this. So divide, D-I-V-I-D, divide by P. Okay, so when I divide across by P, alright, I'm basically going to cancel my P's. And what I'm left with is 1.2 is now equal to 1 plus I to the power of 8. So I don't have a P anymore, and I'm going to be able to work around this. I need to isolate, get rid of this 8. Okay, so what I do is I have to find the cubed root or the 8th root of it. Okay, so what I'm going to do is, I'm just going to do it over here. To get rid of the 8, I'm getting the root of 8 is to 1.2. Sorry now. Okay, and you're going to put that in a calculator, and that's going to be equal to 1 plus I. Okay, now when you put that into a calculator, you're going to come out with a really long figure, but keep that there for a minute. Now this interest rate is over 100, because remember it's 100%. Okay, the interest rate is on the full amount of the investment, so 100%. So what we're actually going to do is we're going to say this amount, okay, is going to be, this is 1.02 when you put it into a calculator, okay? I'm going to make this a little bit smaller just so we can have more room. Is going to be equal to the 1 plus I over 100, but we're actually going to take away 1, and it's just equal to I over 100, okay? So I need to get rid of the 1. So what I'm going to be left with then is I'm going to need to multiply to get rid of my 100 here. I need to multiply. Need to multiply by 100. So what does that mean? That means I'm going to say 100 times 1.02 minus 1 is going to give me I. And when I do that, I'm just going to switch modes here now. When I do that, I'm left with, in a calculator, I get 2.305 is equal to I. So basically, I is 2%. Okay, but remember, when you're solving these, whatever your power is or your time in years, you're going to have to find that in the root. So when you're trying to get rid of this, you need to divide it off or find the root of it, okay? And then over here, the I is out of 100. all right, because it's a certain percentage of the investment, and the investment is 100% of the cost. So when it's divided here, you need to multiply it to get rid of it. If you want to get rid of something, you have to do the opposite of what it's written. So it's written now as a divide, I divided by 100. So to get rid of it, we need to multiply by 100, and that's where you'll get this answer here. So for part A, we're asked to find the value of the investment at the end of 3 years if he chooses option 1. And option 1 is where the money can be taken out at the end of year 1 or 2 without a penalty. So basically, we need to see how much it's going to mature over those years, and it's over 3 years. The interest rate for year 1 is 2%, year 2 3%, year 3 5%, and the amount he invested is 8,000. So very simply, for part A, what we're actually going to do is we're just going to say 8,000, and we're going to multiply it by 1.02 for the first year, 1.03 for the second year, and 1.05 for the third year, because the investment is 100% plus the 2, the 3, and the 5% each year. So that's where I'm getting 1.02. And when we solve that, then we're going to get 8,825.04. So that's if he goes with option 1. For option 2, then it's compounded by 3.7% for 3 years. So the percentage doesn't change, and the time being 3 years is the same, and so is the investment. So for part B, what we're looking at is the formula we're used to. So the P with 1 plus 0.037, and that's over 3 years. And when you put that into a calculator, you're going to come out with 8,000. This time it's going to be 921.26, and that makes sense because the interest rate is 3.7 over the 3 years. Paul would like his investment of 8,000 to amount to 9,000 at the end of the 3 years, and he wants to know what annual rate of compound interest would be required for this to happen. So another way of saying find the AER. Okay, so fill in what we know. Okay, so he wants the future value of his investment to be 9,000. His current investment amount or principal amount is 8,000. We know it's for 3 years, but we want to know what the rate would be. So what we're basically saying is we're going to look at this and say, let's fill it in. So he wants his future value to be 9,000. All right. That's going to be equal to his principal amount, P, with 1 plus whatever the interest rate is, remember, divided by 100 because it's 100% of the cost, and that's going to be to the power of 3, okay, for 3 years. Now, first things first, what we need to do is we need to divide these two amounts here. We need to divide these two amounts, okay? And what we're going to do is we're going to say 9,000, that's 90,000. 9,000 divided by 8,000, that's going to be equal to 1 plus I over 100 to the power of 3. Now, remember I said to you, before you solve the 9,000 over the 8,000, we need to deal with this 3. And I said to you, when it's raised to a power, you have to get the cubed root of it. So what we're basically saying we're going to do is we're going to find the cubed root of whatever 9,000 divided by 8,000 is. And the reason I said don't divide that yet is you're going to get a more accurate answer if you put this all in together. And that's going to be equal to 1 plus I over 100, whatever that is. Okay, so just make this a little bit smaller here now. So when we solve that, we're going to be left with a total of 1.04. This is going to work out as 1.04. It's going to be equal to 1 plus I over 100. Now, I need to isolate this 1. I need to subtract it from the 1.04. So what I'm going to say is 1.04 take away 1 is going to be equal to I over 100. Now, bringing that up here just to continue it on, When I subtract them, I'm going to be left with 0.04, okay? That's going to be equal to I over 100. Now, I said to you that to get rid of this 100 on the bottom here, okay, we're going to have to divide. Or apologies, it's divided, so we're going to have to multiply by 100. So what I'm going to have to do is I'm going to have to say 100 times 0.04 is going to give me what I is, which we know it's going to be 4%. So he has to have a compound interest rate of 4% if he wants to earn 9,000 at the end of the 3 years. Okay, so another bank is going to offer to invest his 8,000 in a special fund, and basically this is the formula they're going to use to calculate the future value. So where V is the value in the fund in euro and T is the time in months, since 8,000 was invested, we have to find the value of the money in the fund after 12 months. So we're basically, what they're telling us, okay, in simple terms, is that T equals 12. Okay, T equals 12 months. That's it. That's all they want us to know. So V basically equals 8,000. This time we're adding 36. It's a funny looking tree. 36 times 12, because T, minus 1.2 times 12 squared. T squared. So when you put it in the calculator, it's going to give you 8,259.2. So he's basically going to earn €259.20. Now, Mary wants to invest for part 2, the 8,000 for 1 year at R% per annum. After her 1 year investment is worth the same amount as the answer in part E above, find the value of R. So she wants to know that if she invests this amount, what's her annual rate of interest. So what you're going to basically do here is you're going to say the amount, which is 259, is how much they earn on the investment, 0.20. You're going to divide that by 8,000, okay? And you're basically going to multiply by 100 because you want the percentage. And that's going to give you 3.24%. So that's how much the interest rate has to be in order for Mary's investment of 8,000 to have the same value as the above amount there.